Hi, this is Dr. Rick Ferguson. Today I'd like to demonstrate how to bring in an opposing arch and align it to an arch that's already aligned to a jaw scan in Blue Sky Bio. Now, if you have an optical scanner, you don't need to do this step because you can actually generate a bite scan and then align the opposing arch to that bite scan, or align both arches to that bite scan. However, if you don't have an optical scanner, this is a workaround using bite registration material to take the bite intraorally and then scan that bite registration in a cone beam CT. So here I've actually brought in an upper arch, aligned it with the jaw scan, and now I'm going to bring in the lower jaw scan and align it to the upper using this bite scan technique from the CBCT. So the first thing you need to do is take the bite registration intraorally. And the way you want to do this is have the patient bite their teeth together and then inject the bite registration material around the arch, pressing it into place against the teeth so that you get a clean indentation of the teeth in the registration material. Then you're going to take that bite registration, place it in the CBCT, and scan it with the CBCT to generate a DICOM file. So we've already loaded the upper jaw here. We've loaded the lower jaw into the Blue Sky program. However, the lower jaw is not aligned to the upper jaw. So we're going to now import the DICOM we've generated from the CBCT. We're going to go to import it as an impression scan. There it is. We're going to import it. It's going to load it, and we'll see this screen here where we can now reduce our volume of interest. Go ahead and reduce that down to just the bite registration. Okay, that looks pretty good. It's going to generate image. This is a 3D rendering. The threshold is usually pretty good. If you see any holes in there, you want to eliminate holes by moving the slider back and forth. We're going to click next, and it's actually going to generate a surface model from that rendering. Once that surface model is generated, we're actually going to go ahead and cancel here, because what we want to do at this point is actually export this impression scan here as an STL file. So we're going to go ahead and export data. Make sure you uncheck all the boxes except the impression scan, which is actually a bite registration scan. We're going to go ahead and export that bite scan and save. We can now open that bite scan in Mesh Mixer. And the first thing we're going to do is look at the image and make sure that it's closed. It's a closed STL file. We're going to go ahead now and actually remove the outer layer by clicking select. Remember, these are hollow files, and we're going to start to paint in the image here just to remove the outer layer of that file so we can see the underlying image of the teeth. That looks pretty good. We're going to go ahead and hit delete, and there we go. We can do a little bit of extra cleanup here. We can do a little bit of extra cleanup here on the side by going to select again and eliminate this flange here, because we're really not interested in that information. What we want to do is just have a good registration of the teeth. Hit delete, and we can do the same thing for the upper. We can continue around the arch the same way. just going to use the cut tool here. Select tool and then delete to cut that away. Same thing here as well. And basically just clean that up. Of course you can do a lot more cleanup than this if you'd like. It's up to you how much you want to do. It's not all that necessary to do a ton of cleanup here. That looks pretty good. You see I accidentally cut a hole in the mesh here, but that's not that significant. So once that's done, we can go ahead and select the entire image by double clicking with the select tool again. We're going to go to edit and flip normals, and now we have our byte scan basically. So now we can go ahead and export that file, export, and we're going to call it inverted byte scan. Let's go ahead and save that. Now we can close Mesh Mixer. We don't need to save that. Go back and we're going to open Blue Sky, and we're going to import this inverted byte scan by just simply dragging and dropping it into Blue Sky. So here it is. Now the software automatically wants to align by teeth. We don't want to do that. We're going to go ahead and hit cancel. Now you can see that the byte scan is not aligned to the model, to the jaw scan. So the way we're going to accomplish that alignment is by going to surfaces first, turn on the maxillary image, which is what we're going to align it to. We're going to turn off original because we don't need that right now. We can go ahead and take a look at both of these images. They're not aligned. And now what we can do is go to model manipulation. We're going to take our inverted byte scan and align it, but we're not going to align it to the CVCT jaw scan. We're going to align it to the maxillary model. So we're going to click by points, align to model. We're going to choose the correct model. We're going to align it to the maxillary model and align by points and hit OK. Once that's done, we can maximize this screen, bring the two images into view so that they're similar. And what we're going to do is we're just going to pick points. So for example, here we've got a cuss tip. Click points here to align. Right here, that's pretty good. That tooth is a little bit out of whack, but it'll serve our this file will serve our purposes. Just pick some good points of clear data. We can choose the midline here. Let's make sure we're keeping track of our points, that we have equal numbers on both sides. Let's rotate this around. And again here, you can choose this little groove right here and here. And then maybe the cuss tip here as well. That one didn't come out so correctly, so we're going to change that. All right. And for the maxillary, we can actually choose some points on the occlusal surface as well. So for example here, on the lateral, right at the edge, and also on this lateral here, right at the edge. And hit OK. And now what you see is that the two files are merged. Scan of the upper could be from a CVCT image of the upper a model or a VPS inversion, and then the byte registration is now aligned to that. We can actually check that in our slices, in our cross-sectional slices, by making sure that the maxillary model is turned on in the hint. And we can now go to the level of the teeth, and we should be able to see both files pretty much aligned accurately. We can actually go through and visualize in each slice as well around the arch, and we can see that we have a pretty good alignment. So now that we've got bite aligned to the maxillary model, we can then turn on our mandibular model. You can see it's not aligned properly to the upper. So what we can do now is go ahead and go to model manipulation again. This time we're going to align our mandibular model. We're going to align to model by points. Going to align it to the inverted bite scan. And again, it'll bring up our alignment boxes. And so this time we're going to align the bottom model. Now the mandibular alignment is a little bit more difficult because we have the overlap of the teeth. So what you have to do is choose points that you can sort of see on the lower, that match up on the lower, maybe not on the occlusal surfaces though for sure. So what we're going to do is choose the midfacial point here on the canine. That looks pretty good. In this case we have a cuss tip for a molar back here. We can choose that as well here. Then we can go around the arch and see if there are any more areas where we can find good data to align. And you can see here, there's a little groove right here that looks pretty good. And here. And then actually we have a cuss tip here because we have a missing tooth that we can align here for the lower jaw. And then maybe at the midline here as well. And the midline here as well. So that should be pretty good. We're going to go ahead and hit OK. You can see now we have both arches aligned to the proper bite. We can go to our surfaces and now again check all of these by turning on the maxillary model is on, the mandibular model is on, and the inverted bite is on. And we can look in our slices, make sure that the hints are all on as well. And in our slices, our cross-sectionals, and our axial, we can check the alignment of all of these different models. So you can see in the cross-sectional here that our bite is aligned properly. Can go around the arch. There are some areas where the teeth are just not going to touch, and that's actually how it is in the patient's mouth. But you can see for the most part, everything's aligned pretty well. Here we are in the posterior. Here as well, and some areas where the patient's missing teeth, you won't have any bite there as well, but we can see for the most part. You can do some refinement by using the adjust model position tool as well. And what I usually do is go ahead and remove the inverted bite scan from the image. And we can actually do a little bit of manual alignment if so needed. But in this case, we don't really need to. It looks like it came in pretty good and we've got the bites aligned properly. So the other thing that we've done here, and we did this previously, was let's turn off the model adjustment, manual adjustment. And we've actually already brought in an implant and a virtual tooth, and you can see that it gives us really good information about our occlusion with our virtual tooth, and also we can see that the trajectory of our implant is lined up so that the occlusal forces will be favorable to that implant. You can see the trajectory here. So I hope this was helpful to folks to help with their implant planning. One of the things that I've seen in academia is folks talking about virtual teeth not being accurate because we don't have the patient's occlusion. So this gives you another tool to bring in the patient's occlusion and allow your digital wax-ups and your virtual teeth to be more accurate to guide your implant placement. Thank you, and please direct any questions to Dr. Ferguson, drferguson@aol.com. Thank you.